In this project, we look at the impact of wastewater on the communities of our rivers and creeks. Currently, we're looking at periphyton, the so-called biofilm that typically grows on stones or riverbeds in the creeks. In these flumes, the water runs in circles. We have an input and an overflow, so the water is regularly exchanged and allows us to run experiments with a mixture that is predefined by the mixing unit that comes before. For example, here we have 80% treated wastewater mixed with 20% of surface water coming from the creek. We are comparing 5 different types of water. Here you see the buffer tank for the creek water pumped directly from the creek nearby. What you also see in this tank is the steel pipe in there, which serves as a heat exchanger. In this experiment, we want all different types of water to have roughly the same temperature, but treated wastewater may come in with a higher temperature than the creek water, and therefore the heat exchanger serves to reduce the difference of temperature by plus -1 degree. The second buffer tank receives wastewater from a regular wastewater treatment that has no additional treatment for micropollutant removal. So this is the quality of water that today's wastewater treatment plants discharge to the creek. This wastewater is either conveyed directly to the flumes to be mixed with surface water, or treated with an additional technique and then brought to the flumes where it's mixed the same way with surface water. We now have a look at 3 technologies that we are looking at in the current experiment. This is the granular activated carbon filtration. Its speciality is to remove micropollutants. Dissolved compounds like pharmaceuticals or hormones are adsorbed on the carbon, and therefore the wastewater fed at the top will be depleted when it comes out from the bottom. This is the membrane filtration. 50 plates like this one here are inside this box, and wastewater, when it passes through this filter, is depleted from microorganisms because the microorganisms are too big to pass the pores of this filter. Now micropollutants are way smaller, therefore they pass through, and micropollutants, hormones, pharmaceuticals are not removed by the membrane. Membrane filters are applied where pathogens need to be removed from the wastewater. This is the last treatment that we looked at in our experiment. UV disinfection kills microorganisms by radiation, by light. Dissolved compounds or particulate matter, which is not alive, passes this treatment almost unchanged. We thus can compare 5 types of waters in our flumes. Only surface water, our reference, then conventionally treated wastewater, 80% with 20% of surface water, then the 80% of wastewater treated with granular activated carbon filtration, plus the 20% of surface water, the membrane filtered wastewater, plus the surface water, and finally the UV treated wastewater, plus the 20% of surface water. In the flumes we grow biofilms so that we can analyze the effect of the different types of water mixtures on the organisms that grow on stones or here on glass plates. For each type of water, we look at its effects on the biofilm that we grow in the flumes. For example, the sensitivity on micropollutants.